Hey everyone, and welcome. Today we are diving into a concept that honestly sounds a little backward, but it is the absolute secret sauce to modern software. It's called inversion of control. We're going to see why giving up control of your code is actually the best way to take it back, and how the Spring Framework totally mastered this powerful idea. So let me just start with a question. Who's really in control of your code? I mean, the obvious answer is, well, I am. I wrote it, right? But what if I told you that the secret to building really powerful, flexible applications is to let go, to actually give that control away? I know, it sounds a little bit crazy, but stick with me here. To really understand why letting go is such a game changer, we first have to look at the old way of doing things, the traditional way of writing code, and the tangled mess it usually creates. Okay, so think about it the old way. If your order service needs, say, a payment processor, it just creates one itself. New payment processor. Simple, right? But here's the catch. This creates something we call tight coupling. Your service is now permanently chained to that one specific processor. What happens when you need to switch to a new payment system? Well, you've got to crack open the order service and basically perform code surgery, which then creates this ripple effect of changes all across your app. And that right there is the real killer. That rigidity. Your code becomes fragile and brittle. Trying to scale it up is a nightmare. And what about testing? How do you test your order service without actually charging a real credit card every single time? It's almost impossible, because the two are just so tangled together. For building modern software, this is basically a dead end. So, what's the solution? How do we get out of this mess? Well, we flip the entire model completely on its head. Instead of our code trying to control and create everything, we let something else take charge. We invert the control. And this brings us to inversion of control, or IOC. The principle is actually pretty simple. We let a framework handle all that low-level management. So instead of you, the developer, creating every object and connecting all the dots, the framework does it for you. You're no longer in charge of the plumbing. The framework is. See? The control has been inverted. And this quote just perfectly captures the heart and soul of the Spring Framework. It is now responsible for creating objects, wiring dependencies, and managing their lifecycle. Just think about that for a second. You're not manually building and connecting every little piece of your application anymore. You hand that whole job over to Spring, which frees you up to focus on the important stuff, the business logic, while it takes care of all the background plumbing. Okay, so the big idea, the what, is inversion of control. But how does a framework like Spring actually do it? What's the real mechanism that makes this whole thing possible? The how is a super important design pattern called dependency injection, or DI for short. You can think of it like this. Inversion of control is the goal. It's what we want to achieve. Dependency injection is the technique, the tool we use to get there. They're really two sides of the same coin, and it's this really elegant three-step process. First, your object just declares what it needs. It doesn't create anything. It just says, hey, to do my job, I'm going to need a payment processor. Second, the framework looks around and finds a component that fits that description. And finally, the framework provides or injects that dependency right into your object where it's needed. The service gets exactly what it asked for without having any idea how or where it was made. Now, Spring gives us two main ways to do this injection. First up is constructor injection. This is where dependencies are passed in the moment an object is born, through its constructor. This is perfect for mandatory, essential parts. The object literally can't even exist without them. Then you have setter injection, which adds dependencies after the object is already created. This gives you a bit more flexibility, and it's great for things that are optional, components that might not always be needed. All right, so let's bring all this theory together and see how it works in the real world with the Spring Framework, which is our powerful IOC container. And it really all boils down to this. Every single resource an object needs is injected into it by the framework. That is the core engine of Spring. It manages this whole universe of objects, which in Spring speak are called beans, and it delivers them exactly where they need to go, right on demand. And you'll hear this whole process called wiring, or sometimes auto-wiring, in the Spring world. It's the perfect term, right? It's the act of Spring connecting all of your different components together to build a fully functioning application, just like an electrician wiring up a house. So you might be asking, why do we go through all this trouble? Well, the payoff is huge. First off, you write way less boilerplate code. Testing becomes an absolute breeze because you can just inject mock or fake components to test parts of your app in total isolation. And at the end of the day, it just forces you to have a better, more modular design, which leads to reusable components and a truly decoupled system. And just to give you a sense of the sheer scale of this, every single time you start up a Spring Boot application, its auto-configuration feature makes over 200 of these configuration and wiring decisions for you, automatically. That is 200 things that you don't even have to think about. So when you look at it that way, inversion of control isn't really about losing power. It's about gaining focus. By letting the framework handle all the tedious plumbing, you're free to solve the real business problems and build the features that actually matter to your users. You give up control of the boring stuff to get back control of your creativity. So the real question is, what will you build?